Welcome Algebra 1 students. Today we are talking about imaginary numbers, so make sure you have your notebook out ready to take notes. Up until this point in your math career, we have been in this world of real numbers. That is all that we have dealt with. So our counting numbers, starting from 1 and going up, our whole numbers, which include 0, the integers, which start to include those negative numbers, rational numbers, which mean that they have a definitive end to them, and then irrational numbers, which continue on forever, like the square root of 2. If you type that in a calculator, it just keeps going. Pi, we all know, is an infinite number, and it doesn't stop, as well as other numbers like e. But now we're going to start diving into the imaginary world of numbers. So why do we need this complex number system? We're doing just fine with our real numbers. We have seen that when we graph quadratics, you can have one solution, meaning one root. You can have two solutions, but sometimes this parabola doesn't cross the x-axis. So we don't have any real solutions, but we have what's called imaginary solutions. Or if we're trying to solve an equation, x squared equals -1, which means that we need to take the square root of both sides. So x is the square root of -1. Well, if you try to put that in a calculator, that gives you an error sign because you cannot take the square root of a negative number. So we need this complex number system for those two reasons, plus many more. So in imaginary numbers, we have this thing called I, and we're defining I as the square root of -1. So then I squared is -1, because if I square both sides of these, that means that it comes out of the square root to be 1. So if we are trying to solve this, going back to the first slide, that means I have to take the square root of both sides. So x is going to equal the square root of -1, which means that x equals the imaginary I. So let's use this with some algebra. I'm taking 3i and I'm squaring it. Okay, so we know that we have to apply that exponent to both of these. Well, 3 squared we know is 9. Well, I squared from the last couple slides we know is -1. So 9 times -1 is -9. Now, if I have the square root of -13, I can break this into the square root of -1 times the square root of +13. Well, I know that the square root of -1 is I, and the square root of 13 can't be broken down anymore. So I have I square root of 13. Now we're treating this imaginary I just like we treat variables when it comes to combining like terms. So if I wanted to simplify this expression, the first thing I have to do is distribute this negative to this back half to be 2 plus 3i plus 1 minus 6i minus 8 minus 7i. And we're going to find those like terms. So I have 2 plus 1 minus 8 2 plus 1 is 3. 3 minus 8 is negative 5. And then I'm going to combine my i's just like you would combine your x's. So 3i minus 6i minus 7i. So 3 minus 6 is negative 3. Minus 7 is negative 10i. Okay, but these are not like terms because this is our imaginary term. Okay, and then if I wanted to multiply with them, I would do the distributive property to get 3i squared plus 4i. But remember that I squared is negative 1 plus 4i. 3 times negative 1 is negative 3 plus 4i. Okay, so using those rules that we had at the beginning. All right, so looking at this one, it seems simple enough, but I know that I'm going to have some imaginary numbers here because I have the square roots of negatives. So what I want to do is I want to break each of these up. So I'm going to break this one up into the square root of negative 1 times the square root of 3 times the square root of 4 because I want the perfect squares in there so that they reduce. This one I'm going to break up into the square root of negative 1, the square root of 9, and the square root of 3. The reason I do that is because the square root of negative 1 becomes I. Square root of 3 is going to remain the same because I cannot simplify that anymore. And the square root of 4 is 2. Same thing here. The square root of negative 1 is I. The square root of 9 is 3. And I can't do anything with the square root of 3. So I'm going to rearrange this a little bit so it just looks a little nicer. It's going to become 2i square root of 3 minus 3i square root of 3, because we kind of want the coefficient, then the I, then the radical. Now, these are like terms. They both have i's in it. They both have square roots of 3 in it. So 2i square root of 3 minus 3i square root of 3 is going to be negative 1i square root of 3.